What if everything you thought you knew about time, that's just this constant forward-moving line, ticking away second by second, what if that was only one way of looking at it?
Yeah, just one perspective.
What if the very fabric of time could be understood, maybe even experienced, in totally different ways, different forms, different flows?
We're radically different, potentially.
Welcome to the deep dive. We plunge into some pretty mind-bending topics and, well, try to bring you the core insights, the surprising stuff, and those moments that make you go, aha, without all the noise.
Walk you through the overload.
Exactly. And today, we are really challenging one of our most fundamental assumptions, time itself. We've taken a deep dive into some fascinating sources, especially this really groundbreaking paper called Chronomorphic Synthesis by Skylar Fiction.
It's quite ambitious.
It really is. It's not just abstract thinking, it's this bold attempt to fuse insights from totally different fields, neuroscience, quantum physics, even cultural anthropology, to suggest a whole new way of understanding time.
Yeah, pulling together threads you wouldn't normally expect to see in the same place.
So the big question we're kind of wrestling with is our usual linear, clock-driven experience of time really universal? Or are there other ways, maybe even more fundamental ways, that time operates and how we perceive it?
A fundamental question indeed.
We're going to start by looking at three areas that seem, well, pretty unrelated at first. We'll let them kind of clash a bit, create some tension.
And then see where they connect?
Exactly. And surprisingly, see how they might synthesize into something new. We'll kick off with the latest on how our brains actually encode time. Then we'll jump into the really counterintuitive world of quantum physics.
Always a trip.
Always. And finally, we'll look at some ancient wisdom, some vastly different ways of understanding time from certain indigenous cultures.
Fascinating stuff.
By the end of this deep dive, hopefully, you'll have a shortcut to being really well informed about this radical new perspective on time. We're aiming for those surprising facts that might make you rethink your own daily experience of, well, reality.
Prepare for things to get a bit weird.
Yeah. Prepare for your perception of time to get a little chronomorphic.
Good word for it.
Okay, let's unpack this. Our first stop on this journey is right inside your head. Specifically, this small but incredibly powerful area of the brain called the hippocampus.
Right. The memory center, traditionally.
Exactly. For years, we mostly knew the hippocampus as the brain's GPS, right? Responsible for spatial navigation, mapping our surroundings.
Like remembering how to get home or where you left your keys, that sense of where.
Precisely, your mental blueprint of places. But Howard Eichenbaum's work, which is discussed in the Chronomorphic Synthesis paper, adds this whole new layer. It's fascinating.
He found something unexpected.
Totally. They discovered these specialized neurons they actually called time cells. Now imagine your brain having its own internal stopwatch, kind of.
But not quite like a clock ticking seconds.
No, not like that. It's more like a series of specialized neurons that fire in sequence, marking the order of your experiences. And crucially, they don't just fire in response to seeing something or hearing something.
They're not just reactive.
Right. They seem to be actively constructing a temporal framework, purely marking the passage of time during an experience.
Oh, it's an internal mechanism for ordering things.
Yeah. Think about remembering breakfast this morning. Time cells wouldn't just flag coffee and cat food as separate items. They'd fire in a specific sequence. After I made coffee, then I fed the cat, then I ate toast. It's about the order. The paper calls it a new dimension for mapping memories.
So it's not just what happened and where it happened, but in what sequence did it happen?
Exactly. It's like your brain's internal time-stamping system building this event-specific timeline, helping you recall when something happened within that specific sequence. So the hippocampus, known for space, is also profoundly about time, but specifically the ordering of events.
Which is a pretty significant shift in understanding its function.
Definitely. But Eichenbaum's work also points out some lingering questions.
Yeah.
Big ones, actually.
It's never simple, is it?
Never. Most of the experiments focused on one specific part, CA1, and mostly in rodents. So how other brain regions contribute, especially in us humans, is still a bit murky.
Okay, so generalizability is a question.
Right. And here's a really key question for our whole discussion. Is this time coding purely internal? Like, does the brain just spontaneously generate these sequences? Or is it heavily driven by external stuff, sensory input, the rhythm of what's happening around it?
The internal clock versus external cue debate.
Exactly. And that difference matters hugely for how we understand where our sense of time even comes from. Is it something we build inside or just a reflection of the outside world?
It's a fundamental question.
Yeah.
And, what's really revolutionary here is how this pushes memory beyond just where or what. It tells us memory is deeply, intrinsically about when things occurred in sequence. It provides a potential neural basis for how we structure our experiences into narratives, into ordered sequences. And that, naturally, leads to the bigger question. If our brains are wiring time this way, focusing on events and their order.
What does that imply about time itself?
Exactly. Does our subjective reality, structured around these discrete, ordered events, hint at something deeper about the nature of time? Maybe it's not just a smooth, continuous flow after all.
Okay, that's a perfect bridge. Because to really grapple with that, we need to take a leap
Into the quantum world.
You guessed it. Brace yourself. We're jumping into the mind-bending realm of quantum physics. It often defies our everyday intuition, doesn't it?
Understatement of the year. Common sense doesn't really apply there.
Right. So our source material points us to the work of Michael B. Heaney from a 2021 paper in Entropy. Heaney is tackling one of the biggest puzzles in quantum mechanics, entanglement.
Entanglement. The spooky action at a distance.
That's the one. For anyone needing a quick refresh, it's where two or more particles get linked, sharing the same fate no matter how far apart they are. Measure one, you instantly know about the other, even across the universe. Spooky indeed.
Yeah, it violates our sense of locality.
Totally. Now, the standard way of thinking about quantum mechanics, the conventional view, actually has time asymmetries kind of baked into it.
How so?
Well, for instance, wave functions which describe the probabilities of a particle's state are usually set up at an initial time and then evolve strictly forward into the future.
Okay, so there's a directionality there.
And even more famous is the collapse of the wave function. That moment when all the possibilities seem to snap into one single reality when we measure it. That's generally seen as happening only at the moment of measurement, again implying a forward direction for observation.
Right, the measurement problem. It forces a choice, seemingly.
But Heaney proposes something called the time-symmetric formulation, or TSF. It's a radically different description. Instead of a wave function collapsing forwards, he uses something called a complex transition amplitude density.
Okay, that sounds complex.
It does. But think of it less like a wave moving one way and more like a kind of probability map showing how a system gets from state A to state B.
A map of transitions.
Sort of. And here's the mind-bending part. This map works equally well forwards and backwards in time.
Whoa, backwards.
Yeah. So in this TSF view, that collapse we talked about, it's not seen as a fundamental physical thing happening in the universe.
So what is it then?
It's considered an artifact of our epistemic uncertainty, meaning it's down to our lack of knowledge about the system until we measure it. The universe isn't collapsing, we're just finding something out.
Okay, that's a huge shift. The collapse isn't real, it's just us learning.
That's the implication. And the consequences for time. Profound. If TSF holds, it means that at the most fundamental level, the underlying physics doesn't care about the direction of time.
No preferred arrow.
None. It allows for predicting the future, sure, but also for retrodicting the past, looking backwards from a known state.
Retrodicting, like reverse prediction.
Exactly. At this quantum level, past and future aren't fundamentally distinct, which totally challenges our everyday grasp of cause and effect, right? If the basic processes are symmetric, then maybe the past isn't as fixed and the future isn't as open as they feel.
Yeah, that would change everything about how we view reality.
It really would. Now, of course, the paper is careful. This is a theoretical proposal. It hasn't been widely tested. Critics might say it makes the math messy without solving all the interpretation issues.
Sure, the usual scientific caution.
And there's the big question of decoherence. How does this quantum symmetry become the classical world we see, where time does seem to flow one way? TSF needs to fully explain that transition.
Right, connecting the quantum weirdness to our everyday reality. That's always the challenge.
But even as a theoretical tool, its implications for time are just massive.
They really are. The takeaway is potentially paradigm shifting. This model suggests that the arrow of time, that feeling we all have of time marching relentlessly forward, it might not be fundamental.
It's just an illusion. Or emergent.
Exactly. Maybe it's an emergent property. Perhaps it arises from how we, as complex systems, interact with the world, how we gather and process information. It suggests our subjective experience of time might be more about our limitations and perspective than about some absolute inherent dimension of the universe.
So time isn't the stage, maybe it's part of the play?
That's a great way to put it. It moves time from being a fixed background to being a dynamic, possibly relational part of reality itself. It forces us to question that gut feeling we have about time's flow.
Wow, okay. From the quantum level, let's zoom way out to human culture.
A completely different lens.
Totally different. We're turning to how human cultures, specifically those far removed from Western industrialized societies with their clocks and calendars, actually perceive and describe time. And this is where the work of Vera da Silva Sinha, detailed in the source paper, is just incredibly illuminating.
She studied communities in the Amazon.
Yes, the Huniku, Aweti, and Kamaira peoples in the Brazilian Amazon. And what she found is just a stark contrast to our lives. Almost unbelievable.
How so?
Well, first off, they don't rely on metric units like hours or minutes, forget the clock. Instead, they use what Silva Sinha calls rich inventories of event-based time intervals tied to environmental and social cues.
Event-based time, like based on what's happening.
Exactly. Think about dividing your day not by 9 a.m., 10 a.m., but by when a certain star rises, or the time to go fishing, or when this particular plant is ready for harvest.
So time is marked by actual occurrences, not abstract numbers.
Precisely. They even use things like the sun's exact position as a marker, blending space and time. But here's the part that really challenges our assumptions, the truly startling bit.
Right.
The concepts of past and future, as we understand them as distinct abstract categories, they aren't lexicalized in their languages.
Wait, they don't have words for past and future?
Not in the way we do. Not as these abstract containers you place events into. Imagine trying to talk about your week without yesterday or tomorrow, without thinking of time as a line stretching behind and ahead.
That's hard to even imagine. How do they function? How do they talk about memories or plans?
It suggests their language itself doesn't set up that linear framework. Silva Sinha states it plainly. There is no evidence of a conceptual timeline. Their understanding of time seems deeply woven into the continuous flow of natural and social events, not mapped onto an abstract line.
Wow. So time is lived in the events, not measured against a separate scale.
That seems to be the essence of it. And Silva Sinha emphasizes methodological humility here. We can't just impose our Western time concepts onto other cultures. She argues that temporal perception is inherently cultural, tied up with language and environment.
Makes sense. Context is everything.
Right. And while her study is specific to these three communities, its significance is huge. It proves definitively that our linear metric time isn't universal. Event-based time, anchored in cycles and practices, works perfectly well.
That is truly eye-opening. Because if entire societies function perfectly well without a linear timeline, without even words for past and future in our sense.
What does that say about our way?
Exactly. It really makes you question if our deeply ingrained idea of time as a river flowing one way is maybe just a cultural construct. A very useful one for industrial societies, perhaps, but not the only way, and maybe not even the most natural way.
It opens up the possibility that other ways of experiencing time are just as valid, maybe even more attuned to reality.
Yeah, more attuned to the rhythm of actual events rather than an abstract grid.
So where does this leave us? We've got the brain building time from event sequences.
Quantum physics suggesting time might be symmetric at the bottom.
And cultures living time through events, not lines. Neuroscience, physics, anthropology, they seem worlds apart.
On the surface, yes.
But the chronomorphic synthesis paper argues, pretty convincingly I think, that there are hidden connections, parallels that point towards a deeper, unified understanding of time.
Okay, so how do we bridge these gaps?
The central theme that starts to emerge is that time seems fundamentally relational and event-bound. It's not this abstract thing flowing independently. Time emerges from the relationships between events, how they're sequenced, how we perceive them.
Events are the key.
Events are the key. Let's connect the dots. Start with the brain again. Eichenbaum's time cells firing in sequence, mapping out events.
Right, the internal ordering.
How similar is that really to the indigenous Amazonian communities structuring their time around named events, the rising of a star, the time to plant? It's like the brain's event segmentation mirrors the culture's event-based timekeeping.
The neural mechanism reflecting the cultural practice.
Maybe. And the fact they don't lexicalize past-future could align with the hippocampus integrating sequences without necessarily needing a spatial timeline metaphor. Time is the content of the event, maybe, not just its position on a line.
Interesting parallel. What about the quantum angle?
Okay, think about mental time travel. We remember the past, we imagine the future. Neuroscientists find the same hippocampal networks are active for both.
Recalling and prospecting use similar machinery.
Right. Now connect that to Heaney's time-symmetric quantum physics. If quantum transitions can happen symmetrically, forwards and backwards.
It gives a potential physical basis for that mental bidirectionality.
Exactly. It legitimizes it. Maybe our brains are somehow tapping into that underlying symmetry, maybe even using entanglement to reconstruct the past and simulate futures. Heaney's model has no fundamental collapse defining past versus future.
Which aligns with the Amazonian view, too, where past and future aren't these fixed, separate things.
Precisely. They might see memories or feel intentions, more embodied, less linear. Both the physics and the culture seem to reject a rigid arrow of time.
That's a powerful connection.
And finally, space and time. Eichenbaum showed time cells iterate when and where.
Not just time, but time and a place.
Right. And indigenous calendars often blend time cycles, like months, with spatial indicators, like the sun's position, star patterns, plant growth. Time is measured through changes in space.
Spatio-temporal mapping, naturally intertwined.
And then, back to quantum physics, Heaney's TSF describes entangled particles in configuration space-time, combining spatial and temporal coordinates.
So all three perspectives, brain, culture, quantum physics, seem to treat time and space as linked aspects of events, not separate dimensions.
That's the core insight. Events, not abstract lines, are the fundamental units. For our brains, for these cultures, and maybe even for physics itself.
It is quite remarkable when you lay it out like that. This convergence across such different scales, neural firing, quantum mechanics, cultural cognition, it really suggests a deeper unity. It's like they're all speaking the same underlying language of time, just in different dialects. A language based on events, relationships, sequences, not rigid, abstract lines.
It definitely makes our standard Western clock time feel, well, a bit limited, maybe even artificial.
A useful convention, perhaps, but maybe not the whole story. It challenges us to look beyond the clock.
Absolutely. But while these connections are exciting, it's not quite that neat and tidy, is it?
Rarely is.
The chronomorphic synthesis paper itself is good at pointing out the remaining tensions, the paradoxes, things that don't perfectly align yet.
Which is important for intellectual honesty.
Yeah.
What are the main sticking points?
Well, back to those time cells. We still don't know for sure. Are they purely internally generated, a spontaneous brain rhythm, or are they mainly driven by external sensory input?
Right, the internal versus external trigger question.
And it matters. If they're internal, the brain is actively constructing time. If they just reflect the environment, it's more passive. That changes how we think about our subjective experience.
Okay, that's one tension. What else?
The big one. The elephant in the room, maybe. How do we reconcile time-symmetric physics with our overwhelmingly asymmetric experience?
Yeah, if the physics doesn't have an arrow, why do we feel one so strongly?
Exactly. That feeling of time flowing forwards, fixed past, open future, it feels undeniably real. If it's not in the fundamental laws, where does it come from? It's a huge disconnect.
The subjective versus the objective, potentially.
And then within the cultural perspective itself, these indigenous cultures, they don't have words for past future, no timeline concept, but they do plan.
Right. They manage agriculture, anticipate seasons.
They remember history. How does that work without a linear framework? It suggests they have a different mechanism for organizing memory and intention, maybe more cyclical, more embedded in social practice in the environment.
So different cognitive tools for managing time, perhaps.
That seems likely. So these are real challenges to a perfect synthesis.
They are. And the paper tackles them, suggesting a potential resolution based on information asymmetry.
Information asymmetry. Unpack that a bit.
Okay, think back to Heaney's TSF. The underlying quantum description is symmetric paths forward and backward are equally possible, in principle.
Right.
But we as observers don't know everything.
No.
We only gain information after something happens, after a measurement or interaction. That act of gaining information breaks the symmetry for us.
So it's our knowledge, or lack thereof, that creates the asymmetry we experience.
That's the proposal. It's not that time itself is asymmetric, but our access to information about it is. We know the past, because information has been revealed, but the future is unknown. Information not yet revealed.
Okay, I think I get that. It shifts the asymmetry from physics to epistemology to what we know.
Exactly, and you can apply a similar logic to the brain.
Yeah.
The hippocampus might hold multiple potential future sequences, multiple ways things could go.
Like imagining different outcomes.
Right. But it only commits to one sequence as events actually unfold and concrete information comes in, solidifying into a memory. The potential futures collapse into a definite path through the process of experiencing and learning.
So the brain mirrors that information gaining process too.
Potentially. And culturally, maybe indigenous communities don't lexicalize the future precisely because it's inherently uncertain from an information perspective. Instead of trying to pin down specific future points on a non-existent line, they might focus on present intentions, social obligations, ritual preparations, things grounded in current reality that shape future possibilities without needing an abstract future concept.
So planning happens through present actions and relationships, not by mapping onto a future timeline.
That could be the mechanism.
Mm-hmm.
So the synthesis argues that the difference between symmetric physics and our asymmetric experience, and even how cultures plan, might stem from these epistemic limits, what we know and how we learn, plus cultural interpretation rather than time itself having an inherent direction.
That's a really elegant way to potentially resolve those tensions. It's about perspective and knowledge.
It reframes the problem significantly.
Okay, so all this complex weaving brain, quantum, culture, resolving tensions, it's all building towards this core idea the paper calls chronomorphic synthesis.
Right, the central concept.
Let's try and define that. What is chronomorphic synthesis? The name itself, chronos, time, and morphe, form.
Suggests time takes different forms.
Exactly. It's saying time isn't one single thing like that simple river. It's the emerging ordering of events. And that ordering takes different forms depending on the context, the scale you're looking at, neural, physical, cultural.
So time isn't the container, it's the pattern within the container, and the pattern changes.
Yeah, or maybe it's the pattern creating the container. Time emerges from the ordering. It's a dynamic process across scales.
Okay, break down those scales again.
At the microscale, hippocampal time cells doing that fine-grained event sequencing, ordering moments within an experience.
The neural building blocks?
At the macro scale, quantum entanglement potentially underpinning fundamental time symmetries, linking events across space and time in non-intuitive ways.
The deep physics layer.
And at the mesoscale, cultural practices, like the Amazonian event-based systems, providing structures that map events onto social and environmental cycles, giving collective rhythm and meaning.
The human, social, ecological layer.
Right, and the flow of time, that feeling we have. The synthesis suggests it doesn't come from some built-in arrow. It flows because we, as humans, through our brains and cultures, are constantly gathering information, maybe even via quantum processes, and weaving that information into memories, narratives, plans, rituals.
So the flow is constructed, an artifact of information processing and cultural framing.
That's the idea. It's an ongoing structuring of information as events unfold.
Okay. That's a powerful framework. Does it lead to testable ideas?
It does. The paper outlines several really intriguing hypotheses that bridge these disciplines. First, the quantum neural coupling hypothesis.
Quantum effects in the brain, that's pretty out there.
It is, but there's growing interest in quantum biology, photosynthesis, smell. This hypothesis specifically suggests time cells might use quantum coherence or entanglement to help order sequences.
How would that even work?
Well, if they did, then a Heaney's TSF, with its ability to retrodict, could offer a physical mechanism for how memory is reconstructive, how we rebuild the past each time we access it, rather than just playing back a recording.
So our memories might be like quantum reconstructions.
Wow, potentially. Second, the event-based cognition hypothesis.
Linking culture and brain structure.
Yeah. It suggests that growing up in a culture that emphasizes event-based time might actually shape neural architecture differently, maybe favoring contextual memory, holistic processing, rather than linear sequencing.
Like the software shaping the hardware over time.
Exactly. And this could even modulate how time cells fire. You could potentially test this by comparing neural signatures across cultures with different time concepts.
Fascinating. Real neural anthropology link.
And third, the symmetry-asymmetry transition hypothesis. This tries to explain that big paradox we discussed.
How symmetric physics leads to asymmetric experience.
Right. It posits that fundamental time is symmetric, but asymmetry emerges as information flows through neural and social systems. Processes like quantum decoherence, memory consolidation in the brain, cultural rules and language, they all introduce asymmetry by fixing possibilities into actualities.
So asymmetry builds up as information gets processed and recorded.
That's the idea. And intriguingly, this hypothesis predicts that practices designed to reduce information asymmetry, maybe certain kinds of meditation focusing intensely on the present, disrupting narrative thought, might actually modulate our subjective feeling of time's passage.
Could you consciously alter your perception of time flow?
That's the speculative but exciting implication.
These are definitely not just minor tweaks to existing theories. They're suggesting entirely new research programs, aren't they?
Totally. Imagine neuroscientists looking for quantum effects in neurons, physicists testing retrodiction in biological memory, anthropologists and cognitive scientists directly comparing brain activity in event-based versus clock-based cultures.
It demands collaboration across fields that rarely talk to each other.
Exactly. It's a call for a truly unified science of time, looking for connections where we've previously only seen boundaries. How does consciousness shape time? How does time shape consciousness? How does quantum reality play into it? Big questions.
Huge. And it moves beyond just understanding.
Right. Because this isn't just theory. The chronomorphic synthesis paper actually proposes concrete applications, ways to potentially use this understanding to change our relationship with time.
Okay, now it gets really futuristic.
Doesn't it? First, there's this invention concept, the Neuro-Quantum Indigenous Time Interface, or NQITI.
NQITI sounds like something from Star Trek.
It really does.
Yeah.
The idea is a wearable or maybe immersive tech that links your brain activity, specifically those hippocampal time cells, directly with time-symmetric quantum circuits.
Okay, how on earth would that work?
Using non-invasive brain scanners like advanced EEG to monitor your time cell patterns when you're remembering or imagining. Then, quantum circuits, programmed based on Heaney's TSF, would let you explore alternative event sequences symmetrically.
So you could, explore parallel pasts or futures in your mind?
Kind of. Simulate multiple future possibilities, maybe see how different choices branch out, or even revisit past events, maybe traumatic ones, and explore them non-linearly, potentially recontextualizing them, softening their emotional grip by seeing alternative paths or perspectives.
That sounds potentially revolutionary for therapy. Or even just decision-making.
Absolutely. And the indigenous part is key. The interface wouldn't just be abstract. It could feed you event-based cues from nature sun positions, seasonal sounds, plant cycles, drawing on indigenous knowledge to help retrain your brain away from rigid clock time.
Wow. So it blends cutting-edge tech with ancient wisdom.
Exactly. The potential applications they list are compelling. Trauma therapy, creative brainstorming, even ecological planning, helping us sync our activities with natural rhythms instead of fighting against them.
That's NQITI. What's the second proposal?
The second is less tech-heavy, more systemic, chronomorphic education.
Changing how we teach about time.
Fundamentally, it's an educational paradigm shift, teaching kids to perceive time as relational, event-based, cyclical, drawing on indigenous calendars and knowledge systems.
So learning to tell time by the moon phases or plant growth alongside the clock.
Yes, and through social rituals, community events, making time tangible and contextual again. And it would be interdisciplinary, showing kids the neuroscience of time cells, the physics of potential time symmetry, giving them the science behind why time might not be just a simple line.
Building temporal literacy, as they call it.
Exactly. The ability to navigate past and future more flexibly, appreciate cycles, make decisions attuned to ecological reality, not just abstract deadlines. The hope is it could reduce clock-driven stress and foster more sustainable thinking.
It feels like both NQITI and chronomorphic education are trying to achieve a similar goal through different means, shifting our fundamental perception.
I think so too. One through tech, one through learning.
It's genuinely exciting. That blend of high-tech potential and deep ecological or ancient wisdom feels very timely, ironically.
Yeah.
It raises that big question. Could learning to perceive time differently really change our well-being, our connection to the planet? Could it unlock different ways of being human?
It feels like it could. But of course, with such big ideas come big responsibilities and potential problems.
Absolutely. Any truly transformative idea needs critical scrutiny.
And the paper does engage with limitations and objections quite directly, which is commendable.
Good. What are the main criticisms it addresses?
Okay, first, back to the hippocampal studies. The focus on CA1, the rodent models the internal versus external trigger question.
Like the limits of the current neuroscience.
The paper's response isn't to dismiss these, but to frame time cells as a substrate. Even if influenced by external cues, they provide the mechanism for sequencing events, which aligns perfectly with event-based cultural time. The call is for more research in humans, in natural settings, across cultures. Let's see if culture does modulate time cells.
So acknowledge the limits, but see them as avenues for future research. Makes sense.
Second, the speculative nature of TSF and other time-symmetric quantum models.
It's just theory objection.
Pretty much. It's unverified, interpretive issues remain, decoherence isn't fully settled.
Valid points.
The paper clarifies TSF is used as a conceptual tool here to show symmetry is possible under fundamental laws. Even if TSF isn't the final answer, the core idea that quantum mechanics doesn't mandate a time arrow is widely discussed. The synthesis uses it to inspire empirical work. Can we find quantum effects in biology related to time? Can these models explain memory?
So it's a theoretical prod, not a final proof.
Right. Third, the cultural specificity of Silva Sinha's work.
Limited sample size, risk of overgeneralizing from 3 communities.
Yes, and the fact that these communities do plan and remember, just differently. The response emphasizes learning from temporal flexibility. The point isn't that all indigenous cultures are the same or that this way is better, but that the existence of successful nonlinear time systems proves linearity isn't universal. Chronomorphic education should embrace this plurality.
Avoid essentializing. Focus on the diversity of human temporal experience.
Exactly. And finally, the big ethical and practical challenges, especially around NQITI and chronomorphic education.
Cultural appropriation, data privacy, tech hurdles, commodifying knowledge. Huge concern.
Absolutely huge. The paper stresses these must be addressed proactively. Co-design with cultural custodians, respect intellectual property, rigorous ethics for neurotech, consent, security, equity. NQITI is presented as speculative, an inspiration, not a product ready for market. Responsible innovation is paramount.
That's crucial. Acknowledging the risks and committing to ethical development pathways strengthens the whole proposal. It shows they're thinking about the real-world impact, not just the cool science.
Definitely. It moves it from pure speculation towards a potential, albeit challenging, future.
It's about building those bridges responsibly.
So stepping back and looking at the big picture, this deep dive into chronomorphic time, it's offering more than just a novel theory. It feels like it's proposing a fundamental shift in how we see ourselves and our place in the cosmos.
It really touches everything.
Conceptually, the idea that time isn't primitive but emerges from event relationships, that reframes reality itself. Time becomes something dynamic, something we participate in creating through observation and interaction.
A participatory universe, in a sense.
Yeah. Scientifically, it's this radical call for interdisciplinarity. Neuroscientists looking for quantum effects, physicists testing retrodiction in biology, anthropologists studying cognition and time across cultures.
Breaking down silos?
Technologically, NQITI, however futuristic, hints at new forms of therapy, creativity tools, decision support systems that operate beyond linear constraints, experiencing time non-linearly.
Transforming our interaction with information and possibilities.
Educationally, the potential for chronomorphic curricula to build cognitive resilience, ecological awareness, a deeper connection to natural cycles, teaching kids to inhabit time differently.
Counteracting the negative effects of pure clock time dominance.
Socially, the implications are massive. Could adopting more event-based time foster sustainability, reduce stress, challenge economic models based purely on linear growth and efficiency? Could we find a more harmonious rhythm?
A societal recalibration based on a different understanding of time.
And philosophically, it resonates with process thought. Indigenous worldviews reality as events, not objects. It forces us to reevaluate causality, identity, and morality if time itself is fluid and relational.
Who are we if our past isn't entirely fixed and our future isn't entirely open in the way we thought?
It's profound.
It really is amazing how this one concept, chronomorphic synthesis, ripples out and touches almost every aspect of human experience. From the neuron firing to quantum fields to cultural practices to how we might heal trauma or plan for the future of the planet.
It expands our notion of what's possible, doesn't it?
Absolutely. It challenges us to imagine living in a world where our internal rhythms, our cultural frameworks, and the deep structure of reality might actually be brought into closer alignment, where time isn't a cage, but maybe a canvas.
A canvas. I like that. So we've journeyed through this deep dive into chronomorphic synthesis, this radical idea reframing time. Relational, fundamentally symmetric maybe, and deeply shaped by culture.
A tapestry of events.
Exactly. We saw how hippocampal time cells give us a neural basis for event sequences, the building blocks of memory and foresight.
The brain's narrative machinery.
We touched the quantum world with time-symmetric formulations like Heaney's, challenging the very idea of a fixed arrow of time baked into physics.
opening the door to retrodiction and fundamental symmetry.
And we learned from indigenous cultures, like those studied by Silva Sinha, that thriving societies can exist entirely without linear timelines, living by the rhythm of events and natural cycles.
Proves that our way isn't the only way.
And when you weave these threads together, this new paradigm emerges. Time as a dynamic ordering of events, shaped by mind, matter, and meaning. It's a paradigm that challenges us, invites us to rethink education, technology, society itself.
A call to live more intentionally within the diverse rhythms of existence.
So as you go back into your day, probably ruled by the clock to some extent, just consider this. If our experience of time is more flexible, more relational than we usually think, what small shift could you make? Could you try aligning just a little bit more with natural rhythms, noticing the sunrise, the seasons changing? Or could you focus more on the unique quality of events as they happen, rather than just their position on the clock?
Being present to the what and how, not just the when.
Exactly. Could simply paying more attention to the unfolding moments, that first sip of coffee, a real conversation, the feeling of the sun on your skin, could that actually change your subjective experience of the day, the week, maybe even your life?
Food for thought.
Definitely. Thank you for joining us on this pretty mind-expanding deep dive.
It was fascinating.
Keep exploring, keep questioning, and keep challenging those assumptions about the world around you.